Okay, I believe we have started the video. Let me share my screen. Perfect. All right, so in this video, we're going to talk about the reaction mechanism I have chosen for week 8. It's essentially focusing on tosylate, which is a great leaving group. And in this type of reaction, we are trying to convert some sort of alcohol with a hydroxide functional group into a tosylate or tosyl chloride leaving group. Um, and the reason why is because these are very good leaving groups that we can then use in further, substitution, elimination reactions, any sort of reaction that requires us to kick off a leaving group, whether that's through an SN1 mechanism or an SN2 mechanism. Um, so what I'm going to do is kind of zoom in here and go over everything that I've written down and talk about it in a little bit of depth. This should be a 5 to 10 minute video. But the purpose of this, like I said before, is to replace an alcohol functional group with a tosylate functional group. Um, and once again, this is done because hydroxide's a bad leaving group, tosylate's a good leaving group. We'll use this in synthesis reactions, or organic chemists will to further manipulate this, compound or molecule of interest in whatever reaction they choose. So the general skeleton equation is going to look like this. So we have an alcohol or R representing the rest of the alkane with OH attached to it. And then we're going to have tosyl chloride and pyridine. Um, and that's going to create this alkyl tosylate shown right there, right? Um, I've drawn the structures of these individual reactants as well. So tosyl chloride is going to look like this here on the right. It is also known as p-toluene sulfonyl chloride, whereas pyridine is on the left right there. It's going to be a strong non-nucleophilic base that's going to be really important for the prevention of other acid formation like hydrochloric acid. So in this example problem, we have this molecule here on the left. We can see this alcohol. We can see this hydroxide group hanging off of it right there. And we're going to use tosyl chloride and pyridine to convert that hydroxide group into a tosylate leaving group. So we're going from a bad leaving group to a good leaving group that can then be used in different reactions. So question A said is identify the electrophile and the nucleophile. The electrophile is going to be the sulfur atom of tosyl chloride, whereas the nucleophile is going to be the oxygen atom of the alcohol hydroxide functional group. And we'll see right here in part B how that actually works in the curved arrow mechanism for the reaction below. So starting off here, we're going to have this lone pair of electrons on the oxygen atom attack the sulfur atom of this tosyl chloride, and that is going to displace the pi electrons in this sulfur oxygen pi bond system to the oxygen atom itself. Um, so oxygen is accepting electron density right there, which is going to create this intermediate in which we have a negative formal charge on the oxygen atom right there and a positive formal charge on the original oxygen atom of that alcohol functional group. So what's going to happen at this point is the electrons that were displaced onto that oxygen atom are going to collapse, forming that pi bond again, which is then going to kick off the chlorine leaving group. That's going to result in this molecule right here, in which we have that positive formal charge still on the initial or original oxygen of that alcohol functional group. And to get rid of this positive formal charge, we're going to have our pyridine non-nucleophilic strong base abstract the hydrogen, which collapses those sigma electrons between the oxygen and hydrogen onto the oxygen itself, which is going to get rid of the positive formal charge, thus neutralizing, quote unquote, that charge, making it overall zero. It's important to note we're using pyridine or pyridine so that the chlorine atom doesn't instead attack it and create hydrochloric acid. That is going to result in this compound right here, which, if we were to simplify it and abbreviate, that whole bottom portion of the molecule is going to create that OTS group that we were looking for. So this is the final product. Um, this molecule now has a good leaving group that can participate in further reactions, like I mentioned before. So part C says explain electron flow. That was kind of written here in green and also verbally what I have just done there. So we'll move on to the last question, D. D says indicate any regiochemical or stereochemical preferences. So in this reaction, there aren't going to be any regio or stereochemical preferences. The reason why is because the substitution that took place was actually within the tosyl chloride molecule itself, not at the oxygen atom of the original alcohol functional group. So to kind of reiterate that, what that actually means is we'll see here um, the sulfur atom is the electrophile, and the oxygen there is accepting the electron density, and then eventually we're displacing the chlorine right there. But what we'll notice is throughout these reactions, the oxygen of the alcohol group isn't being worked on until the very end when the hydrogen is abstracted and those electrons just collapse back onto the oxygen. So nothing there changes at the oxygen. It's all changing within the tosyl chloride, meaning we're not going to have any sort of inversion of chemistry, no Walden inversion, predominant inversion, or complete inversion of chemistry. It's going to stay the same. Where we could have, some regioselective or stereochemical preferences, would be later on when we use those substitution reactions. If we were to introduce, for example, sodium cyanide, this salt of a nucleophile SN2 reaction, we would then get a backside attack kicked off complete inversion or Walden inversion of chemistry, where we would see some preferences there. But in this reaction itself, there aren't going to be any stereochemical preferences. So with that, I will end the video and submit it. But that kind of goes over the entire process of tosylating or converting an alcohol hydroxide functional group into a tosylate leaving group. Thank you.